we're going to now start taking a look at some relations that have finitely many ordered pairs, and then we'll move on and take a look at some that have infinitely many ordered pairs. If you are following along on the worksheet, which just gives you the problem so that you have to spend less time writing them down, we're at topic 1. So we're on page 1, topic 1, which I've copied here, and here are the directions. So for each problem, we're going to do 4 things. First of all, we're going to write the relation as a set of ordered pairs. Now, for the first 2 problems, they're already written that way. That's one way that a relation can be given. And so for the first 2 problems, part A is already done for us. But when we move on to the subsequent problems, we're going to be taking a look at other ways that we can have a relation described, and then we're going to be converting from that way to describing it this way. Okay. Then part B asks us to find the domain. So I need to define that. The domain is the set, don't need an arrow there, it's just the set of all inputs. Remember, the inputs are the first terms or the x values of all of my points. And then we're asked to find the range, and that's the set of all outputs. And that's going to be the second terms, or the y values of things. Okay. And then we're going to be asked, is it a function? So that's just a yes or no question. Is the relation in question a function? Now, what we're going to do is problems 1 and 2 are very, very similar. So I'm going to work through problem 1 together with you in this video. Then I'm going to suggest that you pause the video and try to work out problem 2. Then you can turn the video back on to check your answer and see if you got it right. And basically, as we work through this first section, there are 8 problems. It's 4 pairs of problems. So we'll do 1 together, and then I'll have you do 1 for practice. Okay, so let's see. I need to clear some space here. So I'm going to just remember that these were my directions, but I'm going to erase them now so that I've got some room to work with. Okay. And so for problem 1, it's already given to us as a set of ordered pairs. So the first thing we have to do is find the domain. I'm just going to write D for the domain. And it's a set. So I'm going to use set braces, but it's not the set of ordered pairs. That's the entire relation. What I'm looking for is just the inputs, or the x values. I'm just going to underline the first terms, the x values are the inputs, and now I'm going to write them down. So here the x value is 1, and then we just put a comma in between things. Now here the x value is 1. I'm not going to write a thing, because that's already there. It happens to occur as the x value of 2 different points. That's fine, it's the same x value. I have listed that the x value can be 1. I'm not going to write it a second time when I'm writing down the domain. Okay. Now 2, that's the x value here. That's not already there, so that's something new for me to write. 3, that's not already there, so that's something new for me to write. So my domain is the set of numbers 1, 2, 3. So now I want to get the range. I'm just going to write R for range. And again, it's a set. So I'm going to have these set braces. Okay. Now, a lot of people find set braces hard to draw. I'm okay if yours sort of looks like a squiggle. That's okay. But don't just use parentheses, because parentheses is what we do around ordered pairs like this. And if, let's just say I'd only had 2 points in here, if I'd used parentheses, it would look like I was talking about an ordered pair rather than a set. Okay. So I'm not super picky that your set braces look beautiful, but they do need to be set braces. All right, so the range, that's going to be our y values. Let me get a different color for that. I'm going to just underline the y values in red. Okay. So let's just list them. 3 is one of our y values. So is 4. So is 5. And so is 5, but 5 is already listed. Okay. So I don't need to list it a second time. There are only 3 numbers that this relation can give as an output. So that's my domain and range. And now we've got this yes or no question, is this a function? So the rule is, if it's a function, each of these inputs has a unique output or a unique y value associated with it. So what I'm going to do is I'm just going to look at these inputs one at a time. If my input is 1, let's see, if my input is 1, I'd be talking about this point or this point, because those both have an input of 1. The output, it could be 3 or 4. That's two different y values that go with this particular x value. So the answer is that no, this is not a function. So it's a relation, it's a set of ordered pairs, but it doesn't follow that rule. If you came to me and said, hey, I plugged in 1 to the relation in problem 1, what do you think I got out? I'd have a 50-50 chance of getting the right answer, because it could be 3 or it could be 4. The other x values, 2 and 3, each do have a unique y value associated with them. It happens to be the same y value of 5, but that's totally fine. This is like hitting a button for a Dr. Pepper, and sometimes you get the Dr. Pepper and sometimes you get the wrong thing, you get the orange soda. This is like having two different Coke buttons and they both give you a Coke. Totally fine there. Okay, so that's problem 1. I'm going to have you pause the video, do the same thing with problem 2. So part A you can skip because it's already given to you as a set of ordered pairs, but what I want you to do is write down the domain, the range, and then tell me whether or not it's a function. Okay? And then tune back in and you can check your answer and we'll talk about, I think the domain and range will be pretty straightforward, but we'll talk through the answer to this question of whether it's a function or not. Okay, so here was problem 2. Here are my answers. My domain is the set consisting of these 4 x values, 2, -3, 0, and 1. The range consists of just 3 values, 3, 2, and 5. And yes, this one is a function. To see that, I want to go through my possible inputs. If my input is 2, well, this is the only point that has an input of 2. So I know for sure if my input is 2, I'm getting out 3. That's the only possible output. If my input is -3, well, this is the only point that has an x value of -3. So I know if I plug in -3 as my input, the output I've got to get is 2. If my input is 0, this right here is the only point with an input of 0. So if I plug in 0, I'm guaranteed I'm going to get out a 5. And if my input is 1, that's the only point with an input of 1. So I know for sure if I plug in 1, I'm going to get out a 5. Now, I happen to get out 5 for these two different inputs, but that's okay. Totally fine that my y value is repeated. This is a function because the x value is not repeated. So there's only one point with each x value, which means there's only one y associated with it.